what if you could have it all? Speed, price, and performance in a single model. Is the new Claude HAIKU 4.5 that model? On the right, we have HAIKU 4.5 right next to Sonnet 4.5. Bam, bam. And on the left, our multi-agent observability system. Let's open up some detailed swim lanes and compare these models side by side to understand Sonnet 4.5 versus HAIKU 4.5. The real question is, what types of work can HAIKU offload from Sonnet to save you and I time and money? Let's double click into HAIKU 4.5 to see how great it really is. Right away in our multi-agent observability system, you can see our agents getting to work, but you can see something really awesome coming out of the new Claude HAIKU 4.5 model. HAIKU is running almost a second faster than Sonnet. Now, this is a really fascinating element of this model. It is absolutely fast. You can see it's got about 10 more tool calls than Sonnet does in the same period of time. We have a 3-minute interval here that we're looking at, and you can see HAIKU has over half a second edge over Sonnet. Now, this is going to change, and this is going to lead us to our first key observation about HAIKU versus Sonnet. You can see HAIKU has decided that it is done working. It is writing its output file. I'm going to break down exactly what this prompt was in just a moment. There we go. So HAIKU has finished its work. So it's got 74 total Claude Code hook events, and 36 of those were explicit tool calls. You can see it took Sonnet a bit more time within this 3-minute interval. While Sonnet is writing its output, let's break down the stats out of HAIKU. There are a couple key things I want to point out here. I see HAIKU 4.5 as the cheap, fast compute for agents. HAIKU 4.5 is a third of the price of Sonnet. So for every Sonnet prompt you write, you could have written 3 HAIKU prompts. Now, it doesn't always work out that way, but that's the way I like to think about this. It's not always about the input and output pricing. You have to look at the cache pricing. Cache hits and cache writes drop the price down even further. This model is cheaper than you think it is. Just to mention it right away, I am not affiliated or sponsored at all by Anthropic or any model lab. I'm an unbiased third party. I comment and I talk about these tools because I focus on using the best tool for the job right now.
All set and ready to go.
Right now, these models are the most important thing to pay attention to. And you heard that there. That marks the completion of both of our models there. So that's HAIKU. And let me move to the 5-minute mark. And I'm just going to take a quick screenshot here so we can come back to this in just a moment. HAIKU 4.5 is a thinking model. This is an upgrade from 3.5. That was a pure base model. This is a very fast model. Some of the benchmarks are reporting 100 to over 200 tokens per second once it gets going. Very powerful. Now, the most important thing we're going to break down in this video is, what are the use cases for this model? When do you use Claude HAIKU 4.5 over Sonnet? Let's go ahead and just take a look at what exactly happened. We saw HAIKU finish in about half the time it took Sonnet to finish. HAIKU finished. The big question here is, did HAIKU 4.5 do the exact same work that Sonnet did twice as fast at a third of the price? Let's find out. Let's go ahead and look at the results of this prompt in this code base. So this is the prompt that we just ran. Find and summarize specific files in the code base. We're looking for Vue and TypeScript files inside of the apps directory. So let's go ahead and see that output file. There's 2 versions. We have HAIKU 4.5 and we have Sonnet 4.5. So if we crack these both open, you'll see that they both wrote the file in the exact proper structure. So if we go split screen mode here, the first thing we need to check is, did both of our models find all the files in this code base? So we can quickly just check this. If we go to the bottom of Sonnet, you can see we have about 96 lines. Bottom of HAIKU, you can see we have 93 lines. So we're seeing another difference here in performance. Let's go ahead and count these, right? On HAIKU, we're gonna just do a quick regex search, dot TypeScript new line. 17 files, right? This regex search gives us all of our TypeScript files. And let's go ahead and do or Vue new line as well. 31 files in total. Let's copy this search, move to Sonnet, and you can see something critical here. HAIKU missed 1 file. Now, 1 out of 32 in some cases is a complete failure. That's a 3% failure rate in some engineering domains. This is completely unacceptable. Now, on the other side, in a lot of domains, 3% failure rate is more than enough. In fact, it's great when you can move twice as fast and spend a third as much. You have to keep that in mind as we're looking through these results, right? There are serious cost speed benefits, so specifically costs and time losses by using these stronger, more powerful models, right? So if you can trade this off, you're going to want to know about that, right? You're going to want to make that trade-off. Now, there is something else very important here that I built into this prompt specifically to compare Haiku to Sonnet. To be super clear here, I'm not trying to hype up Haiku at all. I'm trying to compare these models to understand when we can downgrade and pass off work to a cheaper, faster, more performant model. But if the model can't do the job, we can't give the job to the model. What do I mean exactly? So inside of this prompt, let me just go ahead and collapse everything so you can see classic structure, very easy to understand, very consistent, great for you, your team, and your agents. Now, if we scroll down here to the report format, you can see two things. Both models nailed the report format, so we'd love to see that. But there's an important detail here in our summary, right? This is a 2-sentence summary. In the first, describe the file's purpose and functionality. And in the second sentence, describe where the file is used in the code base. This is more complex, right? This directly adds complexity to the prompt. Let's go ahead and continue comparing. So we have Sonnet on the bottom here, and we have Haiku on the top. Now, you'll notice something. If we search the keyword used on the Sonnet results, you'll see 12 search results of used. And if we look at the second sentence, just at a glance, you can see that the summaries coming out of Sonnet are a bit improved, right? We see that used keyword throughout, and it even mentions when a file is unused. Now, if we search this inside of the Haiku results, you'll see only 2 hits, okay? It serves as a starter template, enables proper type definitions, supports custom styling. You can see here, in general, Haiku completely missed this second instruction, okay? So this is a key difference between Haiku and between Sonnet. I want to showcase not just how good, cheap, and performant HAIKU 4.5 is, but also where it starts to fall apart. Okay, this is cheap, fast compute for agents, but I really see Haiku as a scouter model. That's kind of the best way I can describe it. It's good for search, summary, but for simple tasks. Let's scale this up, right? Let's push this further. We now know that Haiku is fast, it's cheap, it's performant, but it will lose detail, okay? It will lose track of some critical information. Haiku is a fast, hard worker, but it won't work for very long. So let's clear our agents and point them toward a critical task for agentic coding, planning. Let's reset our multi-agent observability and let's fire these 2 new prompts off. We're going to have Haiku and Sonnet plan a brand new feature. We know that great planning is great prompting. This is a critical element, a critical value proposition of agentic coding and of agents. So let's dial into their individual swim lanes and let's see how these models perform side by side once again on a planning task. We're going to have these models plan this set of work. All right, so this is not a trivial planning task at all. They're building out 3 distinct new features. We're going to add 3 new UI themes. We're going to add a 10-minute activity pulse timer. So you can see here right now we have 1, 3, and 5. They're going to plan out the 10-minute switcher there. And then we're going to have a regex front-end only search bar for the agent event stream. All right, so that's this stream right here. We want to be able to search through these events quickly for content. Right away, same trend, right? Haiku is working very fast. On average, the time between tool calls is almost a second faster than Sonnet. You can see that Haiku has called almost twice as many tools as Sonnet. Now, I noticed something here too. Haiku has also made a mistake here that I want to call out. In the prompt, I explicitly state, do not use any sub-agents. All right, so let me just quickly pull that up. Right here. Important, do not use sub-agents to do this. Run your own code to accomplish this task. So here we have Haiku violating instructions in the prompt. It's running a sub-agent. This is bad prompting, whereas Sonnet solved that and did all the searching on its own, one step at a time, reading files back to back. This is fine. We're going to let it fly. It did gather some results. Let's see how it performs. So while these models are outputting their plans, I want to talk about something that's super, super important. Why do we care about Haiku at all? We care for this one reason alone. We care because we can pass off agentic capability between our models. So from Sonnet 4 to Sonnet 4.5, the number of things Sonnet can do has increased. Now, we see that exact same thing from HAIKU 3.5 to HAIKU 4.5, okay? It's not just in that easy problem domain space anymore. It can now solve many of the problems that only Sonnet and only Opus can solve or could solve. And now we're going to see this exact same thing. To be clear, Opus hasn't been released yet, but once it's released, we're going to see hard problems that were just not possible before be solved by that next frontier model. Now, it's a lot easier to compare a Sonnet and a HAIKU together than an Opus to what's the edge of capability that we want to compare it against. That's becoming increasingly challenging as these models saturate and beat every single benchmark. I think the one thing I'm looking at now, the one thing I care about is agentic capability. How autonomous is the model and how well can it understand intent? Now, we're focusing here on HAIKU. There are problems that HAIKU can now solve that only Sonnet or Opus could solve, right? And so what does that mean? It means that we can better trade off speed and cost and performance, right? Keep in mind, for every Sonnet prompt you write, you get 3 HAIKU prompts, right? You're getting 3 to 1 if HAIKU can do the job. That is the critical delineation to make. But now it's important to map out the problem space, right? Easy problems to average problems to really understand what HAIKU can do that you can offload down from Sonnet, right? Just like when Sonnet 4, Sonnet 4.5.
All set and ready to go.
Okay, so our agents are completing in the background there. But just like when Sonnet 4 and Sonnet 4.5 was released, it replaced Opus, right? Why would you wait so long? Why would you spend so much when you can downgrade the model to get the job done? So this is why we care about HAIKU. We care because it gives us a model stack. And so this idea is super important. You want a portfolio of models that you can work with. An agent model stack, weak, base, strong, right? HAIKU, Sonnet, Opus. Okay, and this isn't just relevant to Anthropic models. Like, pick your model stack, right? I don't care what model set you use. I think you should use and try all these models to understand the landscape of agentics, to understand the landscape of generative AI. So we all know that the new Gemini model is in the wild right now. It is going to be shipped soon. It's going to be really exciting. The performance of that looks insane. But every Gen AI company has a model stack, right? You have mini, you have 5, and then you have pro. It doesn't matter what this is for you. It only matters that you have a selection of models where you can trade off price, performance, and speed at will. Why would you spend the time and money on Opus when Sonnet does the job? Same thing applies for Sonnet and HAIKU. Why would you spend the time and money on Sonnet when HAIKU can do it at a third of the price, twice as fast? This is why we care about this release. Now, the real question is, can HAIKU do the job, right? And this is where multi-agent observability, understanding some evals, understanding some benchmarks really comes into play, all right? So both models completed their tasks. Let's see how they've performed. Let's just see if HAIKU can take its plan and build out the feature end to end. And by the way, we are operating on the multi-agent observability code base. We have the agents pointed kind of back at their observability UI here. So let's go ahead and see what was generated there, right? Let's understand the new plan that was created in the specs directory. And once again here, we have another classic agentic prompt, classic structure, very consistent. Purpose, variables, instructions, workflow, report. If you've been watching the channel, you understand why consistent prompting is so important for consistent results, all right? And you understand the value of every one of these sections. They're all distinct and important in their own unique way, all right? Let's look at the plans generated here, right? So if we go into the specs directory, we can see these 2 new plans generated. Let's open them up. And once again, let's understand how they compare. Sonnet on the right, and we have HAIKU on the left. So the most important thing is that they accomplish these 3 tasks. Add 3 new UI themes. So this is HAIKU here that we're looking at. 3 new UI themes. Add 10-minute live activity pulse timer, perfect. And add regex enabled front-end search bar, all right? So it looks like it picked up on all 3 tasks. Let's just do a size check. So if we scroll to the bottom here, you can see another distinct difference between these models. HAIKU works very fast, very hard, but not for very long. Sonnet, on the other hand, has output a file that is 3 to 4 times longer than HAIKU. So you can bet that there's going to be some additional detail here that we could point HAIKU or Sonnet or Opus at that will result in a better build step of the software developer lifecycle. Right away, I think we can make a blanket statement that Haiku is not a good planner. Okay, it's not meant to think deeply. It's meant to accomplish surface level, high level, pattern rich work, right? Summarizing things, simple tasks. All that said, maybe Haiku knows something that Sonnet doesn't. Let's just fire this prompt off in a build higher order prompt. I'm going to run /build, and we're going to have Haiku build the feature. And if it completes the work, then we were off about the importance of the detail that plan actually needed. All right, but let's go ahead and fire it off. Let's see how Haiku performs here. All right, so we're gonna let Haiku get to work here. This is a classic build prompt. This is a higher order prompt where we pass a plan into a prompt. We've talked about this on the channel, and we utilize this concept inside of tactical agentic coding. But you can see here we have a simple format of our agentic prompt: purpose, variables, workflow, report. Haiku is just running and building and implementing this. We do have an ultra think information dense keyword here to activate thinking, but we already had thinking on via the tab key, so this should be good to go. When we look at these models kind of side by side together, this is how I'm thinking about these models, right? They're all thinking enabled now, which is great. This extends performance, but it also extends their price, right? Because they're consuming more tokens. This is expected. We do want to scale our compute to scale our impact. So we like thinking. Something that I would like to see is more fine-tunable thinking out of these models, out of these labs. Right now, inside of Claude Code, we just have thinking on or thinking off, which, by the way, I had thinking off on Sonnet. So it was actually operating at a disadvantage compared to Haiku. So important thing to mention there. So we can see here Haiku working. We do have that 10-minute marker in there. That looks great. Let's see if it comes in with that regex enabled search bar under the event stream under the tags. The breakdown here is pretty much exactly what you expect, right? Haiku is the new fastest model. Again, we're talking 100 to 200 plus tokens per second once things get going. This is something I need to add to the multi-agent observability toolkit here. Right now, we're just measuring kind of average speed, right? Average speed between the tool calls. You can see here that Haiku is very fast, right? Right now, with Sonnet 4.5 and Opus 4.1, those are effectively the same models, but Opus is kind of unusable right now just due to the price, okay? You can see here, the speed breakdown is exactly what you would think relative to the other models. And then we have our cost breakdown. Haiku, again, operating at about a third of the price of Sonnet. You get a lot more out of Haiku if Haiku can do the job, right? And this is the big reoccurring theme when you're talking about performance trade-offs. It's performance, speed, and cost. Those are the three dials you and I have as engineers to tweak and tune as we're building agents with these powerful models. And again, by the way, I don't care what model stack you use. It only matters that you have the optionality to use the right one at the right time, right? This is why we care about Haiku. I had several other ideas that I wanted to share with you today, but when Haiku dropped, I knew it was a perfect time.
And ready to go.
Okay, so one of our agents have finished. When Haiku dropped, I knew that was a perfect time to talk about this key idea. I mean, if you're running a business, like there is nothing more critical than performance, cost, speed trade-offs, right? This is what running a business is all about. How much performance can you get out of the engine you're building, and what does it cost? Can we dial up and down these knobs? When you have a model portfolio like this, right, a model stack, weak, base, strong, you can do a lot more, and you can tweak and tune the knobs when the time is right. All right, so this is super, super critical for scaling your agents across your code base. All right, now let's see what's been done here. So nice, we have our regex bar, 10-minute interval here. All this happened really quickly, right? If I dial up, how long did this take, right? Let's try the 10-minute. Nice, so it looks like 10 minutes. Looks great. Within a span of about, 3 or so minutes, Haiku completed this work. It used 25 tool calls, and the average time between tools was about 4.3 seconds. Okay. We also have 52 total events. And so about half of those were actual tool calls, right? So we are tracking the other events coming out of Claude Code: pre-tool, post-tool, stop, notification, and a couple other ones, right? Start session, user prompt, so on and so forth. But the main work coming out of your agents is always the tool calls. To scale your impact, scale your compute. One of the most direct ways to measure your compute is by looking right here at your tool calls, okay? Tool calls are a rough corollary for results. So the more tool calls in the less time means the more impact you're having, assuming, okay, and this is important, right? You have to caveat all that, assuming the work you're doing is valuable, right? Underneath all the agents, all the new technology, you still have to apply the right judgment to the right problems to generate real value. You have to focus on something that's worth building, worth solving, worth spending time on, worth using agents on. So this is great, right? We have our 10-minute timer. Let's check our regex search. I'm going to directly ask Haiku, what fields can we search on? And I am absolutely loving the speed out of this thing. As soon as it hits the server, you can see it just drilling back tokens, right? Look at that. Here are all the events we can search through. Event type, source app, great. So we should be able to search something like this, right? If I just do stop, all of our stop events and subagent stop, nice. Let's be more specific. Subagent stop, there we go. Look at that. Reads. All right, so we have all the reads in the summary. All right, so here's another one. Filter panel. Let me just search filter. There it is. So everything related to filter panel. So this is great, right? And let's do a regex search. Okay, so what do we want to do here? Let's say event view. So this looks good, right? Event row, event timeline. Very, very nice. Oh, nice. It even gave us a little error here, right? Invalid regular expression. Very cool. So what if we did event nice? Okay, this is looking great. And then of course we can just search pure session IDs for BA5. Very nice. There it is. Only events coming out of that session ID. Okay. So, I mean, implementing front-end regex search, not trivial, also not super complex, right? If we look at the kind of complexity zones we were looking at, I would put this in, low tier average problem to solve, right? And again, this is something that probably 3.5 Haiku, or not probably, 3.5 Haiku could not have coded this, right? Even with a plan like this. Kind of impressive stuff, right? You can see that our time drill works. We can go 1, 3, 5, 10, and we're capturing more of those events. And if we refresh, we should get the latest N kind of events. There we go. Looks good. Okay. And now we have our themes. All right, so did we get new themes? So I'll ask, what are the names of the new themes? Midnight Purple,
and ready to go.
We have Sunset Orange and Mint Fresh. So let's see if this worked, right? So Midnight Purple. Okay, so this did not work. This is the default light theme, and Midnight Purple is not updating to anything. So let's see if, nope, Sunset Orange does not work either. Do we get Mint Green? No. Okay, so these were not properly wired up. I'll bet that it created it, but it missed some critical detail of wiring it all up, okay? And so very interesting stuff there, right? And we can just, validate that directly in the code base. If we open up a new terminal, git stat here to see all the files that were changed, you can see 162 lines. We can quickly just look through this. There's the search bar, right? That looks great. Here are events that are now getting filtered via the search bar. Also awesome. There's that 10-minute interval. Great, great, great. And then here's our colors, right? So it looks like the colors are there, but they're not wired up, right? Something got missed with their wiring, and that's causing the issue with the actual output here, all right? So I'm just gonna go back to our classic dark theme. That's fine. You can see here, once again, Haiku is a very powerful performant model. Would Sonnet have missed this? Absolutely not. I can say that with confidence, Sonnet would not have missed this. It's probably even in the plan, right? There's probably some wiring detail here with the UI theme that was definitely locked in by Sonnet. You can see here, just looking through the plan again, there's a lot more detail here about accomplishing this work. There's the theming functionality, right? All the way down to the exact themes it wants to create, adding the CSS theme, right? This all looks good. But these are details that Haiku just completely missed, right? It's a lot more surface level. Like, look at this. This is all it wrote for that new UI theme. Let's scroll down here, see if there's anything else. Yeah, so it just missed a bunch of details here, right? It has 5 steps for this, so on and so forth. Okay, so we don't need to harp on that for too long. I just want to showcase that, right? We have Haiku accomplishing a lot of powerful work that Haiku 3.5 had no chance of accomplishing, but at the same time, this model is not Sonnet, okay? I wouldn't even go as far as saying that it's Sonnet 4.0, right? It's a bit below that. Although its capabilities are increasing, right? It can solve some average kind of mid-level challenging problems. It is not a Sonnet level model, right? Maybe we would call this, Claude 3.5 Sonnet or Claude 3.7 Sonnet level in some cases, but this is not a replacement for Sonnet at all. And I think that's fairly clear. This is not quite our all-in-one model yet. Right now, Sonnet is still the powerful workhorse model that can do it all for you. That being said, there are specific cases where you want to drop down to Haiku and use Haiku to solve problems. Haiku is great for simple work. It's great for actually coding. It's not a great planner. It's a great summarizer, but it will lose detail, right? You can pretty much expect that whatever you throw Haiku at, if it's not a simple kind of 1, 2, 3-step task, Sonnet will outperform it, but it'll cost you 3 times as much to use Sonnet. Let's break down another example of this at work at scale. So we're going to clear our agents here so that we have fresh context. We're going to clear out our agent system and we'll run this command. Bench run load AI docs Haiku 4.5. Same deal here. Bench load docs Sonnet 4.5 fire. And let's have these run an AI docs parallel search here. Let me break down this prompt. Let's go ahead and open up the swim lane so we can see these models work side by side together. So this prompt is going to pull in several pieces of documentation. So Haiku firing up subagents. Sonnet is getting there. Let's go ahead and dial in the timeframes here. Go ahead and open this up just a little bit more. Now we have Haiku on top with an insane 1.2 second average time between tool calls. The rate here has increased, right? We're deploying subagents against this problem. So things are moving a lot faster. So we have 1.5 seconds here out of Haiku. We have 27 tool calls, and then Sonnet here is running 23 tool calls with a 2.3 second gap. That's coming down here. That looks good. But you can hear our subagents completing their work.
Subagent complete.
And so we're firing off a documentation gathering prompt, right? So this is a perfect use case for firing off subagents, gather documentation, and then we're going to have our primary agents, Haiku and Sonnet, answer specific questions about the documentation. And to be super clear, inside of each subagent, Haiku is running Haiku subagents and Sonnet is running Sonnet subagents. There's the reading coming in there. And so this is an interesting case here where the number of tool calls is going to be closer to the same. This is what you want to see, right? You want to see both Haiku and Sonnet performing the same amount of work, but you want to see that time difference, right? Haiku is writing its answer file and it finished kind of around this point here. And now it's just working through its output tokens. And Sonnet was still working through tasks, still working through things. But you can see here, there's its output file, right? Haiku also wrote the file out, right? And if let's go up to a 5-minute time interval here just to keep track.
All set and ready to roll.
Perfect. So now both agents have completed. We're asking our agents to answer some questions about the documentation. All right. So the idea was here, fetch these documentation pieces. So, some Claude docs, Gemini, OpenAI, and then answer specific questions. All right. So let's see how these models performed side by side this task. You can see here in the end, it looks like the total tools, right? The total compute used to solve the problem, they were about the same. The question here is, did we need Sonnet for this or could we have passed this down to Haiku, right? This is the kind of game that we're playing when these new models are released. So let's break down what they did, right? What's the actual functional work they completed for us, all right? Here's the prompt. They have their instructions. It's best to look in the workflow because it's the actual agentic workflow they're running. Read this file, create the output directory for each URL in the README, fetch them. After they're all fetched, answer each question, all right? And then output a answers markdown file. If we hop up to our questions, you can see we have 3 concrete questions about some of the Claude Code features. So subagents, plugins, and skills. So 2 of these are new features out of Claude Code we haven't discussed yet on the channel. Stay tuned for more of that. Make sure you're subscribed and liked up. But so let's see what they actually generated here for us, right? If we open up AI Docs, we can see that 2 directories have been generated. There's all the documentation for each. So if we dial into a couple of these files here in the AI Docs Haiku directory, it ran a scraping job, right? So simple, not a lot of room for variance here. They just scraped a file and created an output directory and summarized some capabilities, right? So these are both exactly the same. This looks great. Now the interesting part here is going to be in the answers. So here's answers for Sonnet and here's answers for Haiku. Let's put these side by side once again. So Haiku on the left and we have Sonnet on the right. So what are the 3 different priority levels for subagents, project, user, CLI? All right. So if we look at this here, you can see Haiku actually caught a little bit more detail here, project level, lower level, and CLI defined, right? There's this new dash in the CLI that you can pass in, right? And then we can do something like this. And so this is a setting, right? Yeah, dash agents. This is another level of sub-agent priorities inside of the Claude Code system, right? Project level, where you have it in .claude, you have your home directory level, and then you have this dash dash agent level. Interestingly here, Sonnet just missed this detail, all right? So that's question one. Question two, we're looking for the plugin directory structure. All right, so it looks like HAIKU generated a little extra stuff here. This .mcp.json isn't exactly right. Did nest skills here, which isn't exactly right. So you can see a little bit of discrepancy here. You can see it's breaking down the purpose of the .claude directory. That's great. Now here's an interesting one, right? Skills versus subagents. How are they different, right? This is a really interesting question that frankly I had when I started looking at this. How do agent skills differ from subagents in terms of invocation, context, and when should they be used? So here's the respective answers out of this, right? I think this is really interesting here. So we have Sonnet's answers on the right, and we have HAIKU's answers on the left. You can see a very similar structure, right? Whatever their training process is, it's very similar because the results these models are producing are, nearly identical. And, this is a thing that model labs do, right? It's likely that both Sonnet 4.5 and HAIKU 4.5 were trained on Opus 4.x, right? It's not clear what version, maybe 5.x, who knows, right? Only Anthropic engineers know that. But this is a thing that happens often in the LLM space, model distillation, right? But anyway, so you can see here, agent skills, Claude determines when to use these. This is a really interesting new feature. Inside of Claude Code, we have these skills that can be autonomously enacted, right? Whereas subagents also can be automatically called, but we can also explicitly call these as the user as well, right? Great breakdown from both models. I think we're getting some rich, great responses out of both of these models, which can lead us to the summary that, speaking of summaries here, HAIKU is actually giving us a nice summarized response here at the end, right? Comparison table, this is pretty nice. Model-driven, user or auto-delegated, right? That's great. Shares the main context, separate context window, perfect. Discovery, autonomous based on requests, based on explicit or task match. That's exactly right. Best for adding capabilities, best for delegating specialized tasks. Okay, so HAIKU doing a great job with the summarization here of this prompt. Another solid win for HAIKU. This is a powerful, fast, and cheap model. It is very clear that Claude 4.5 HAIKU, it is not as performant as Claude 4 or Claude 4.5, even though it ranked like this. Maybe it does have those same engineering chops. It definitely programmed very well, but in terms of raw power across the board, we can put HAIKU 4.5 kind of a notch below Sonnet 4. And to be super clear, this is still incredible. Again, we're talking about a third of the price. Oftentimes, when I'm booting up my Claude Code instances inside the loop, I stop and I first ask myself, do I even need Sonnet for this now? Or can I drop down to HAIKU? Can HAIKU accomplish this task for me? And for any simple pieces of work, I'm deploying HAIKU to solve that problem instead of spinning up Sonnet. And, we have a perfect example of that. Just to be super, super concrete, we have these agent summaries, right? All of these little agent summaries here that are summarizing the work done. This is being done by, guess what? That's exactly right. HAIKU 4.5, okay? So for every item coming in here, we have HAIKU 4.5 running these agentic summaries on the payloads that are getting passed in. You can see some of these payloads are not super trivial. We are having HAIKU 4.5 create high-level summaries for every single event coming in here. We're talking about hundreds and thousands of events. HAIKU is doing all of it very quickly at high performance, very accurately here, right? Bash tool counts 145, bash tool executing, to do tool write, agent executing bash command, so on and so forth, right? A perfect use case for a cheap, fast model, all right? This is the thing to keep your eyes on as you're improving your agentic capabilities. A great rule of thumb is use HAIKU for file summarization, for structured data summarization, use it for documentation, for simple code generation, use it for pattern matching, and then you want to use Sonnet for the big heavy hitting items, right? Planning, architecture design, debugging complex scenarios, long running agentic coding jobs, long running agent pipelines, right? Secure, production sensitive work, setting up things like refactoring. And that's a great example, right? For refactoring work, HAIKU can probably refactor those files, right? In fact, this is where you would have Sonnet plan the work and then spin up HAIKU subagents to actually do the refactorization work. And then you can have Sonnet just double check the files, using those read tokens versus the actual output tokens. Because again, if you write with HAIKU, you're dropping your price by 3x, right? It's 3x cheaper Said another way, it's a third as expensive. And that's not counting when you start hitting the cache over and over, the price drops even further. So I'm a big fan of this model. I think this was important enough to kind of halt some of the other big agentic orchestration work that I wanted to share with you. More on that coming in the future. The link for this code base, for the multi-agent observability code base, is going to be available to you in the description. Observability and orchestration is the next frontier for agents right now. I'm spending a lot of my research and experimentation time right here focused on this. All right. So all the work we've done here and all the work that you're likely doing is being done what's called inside the loop. You're prompting back and forth with your agents. Maybe you have some great custom slash commands set up, right? Slash XYZ, and then you can do, some amount of work with your agents. That's all great and fantastic, but this is just one mode of agentic coding. There's two, and if you're at the edge, there's three, but there are two primary modes of agentic coding. Most engineers are stuck in the loop, prompting back and forth, which is why I built tactical agentic coding. I've been talking about this on the channel week after week, so I'm not going to harp on it too long here. The idea is simple. We need to scale far beyond AI coding and vibe coding and start becoming agentic engineers. All right. You will develop techniques and tactics so powerful with agents that your code base will run itself. This is advanced. This is not simple. If you're a noob or vibe coder, this course is not for you. So there are two distinct courses inside here. So tactical agentic coding is the core essential 8 lessons. And then if you want, you can upgrade, right? This is an upgradable extended mastery lessons to Agentic Horizon. For all of my Agentic Horizon members, the 4th lesson is in progress right now. I'm going to be delivering that to you early October, so stay tuned for that. Right now we have 3 lessons available. The 4th lesson is on the way. Your votes are all in. We're going to be pushing on that. If you're not an Agentic Horizon member yet, hop in here, get the first course, get the second course, and then place your vote. There are still 2 more coming after the release of lesson 12 inside of Agentic Horizon. I'm really excited to share that with you. I'll make sure to announce it, of course, on the channel when this lesson drops, but stay tuned for that. We are pushing hard into the next frontier of agentic coding. We're deploying agents all over our code base. If you've taken tactical agentic coding, you understand the paradigm shift that's happening right now. Better agents, more agents, custom agents, and soon the big idea we'll be talking about in the next Agentic Horizon lesson is agent orchestration. Like you saw here, it is super, super critical to be organizing and observing your agents. There's 2 big ideas we're pushing into on the channel and inside of tactical agentic coding: multi-agent observability and multi-agent orchestration. You know where to find me every single Monday. No matter what, stay focused and keep building.